More related rate problem. So an aircraft is flying at 450 feet per second with elevation of 115 feet from the ground on a straight line path that will take it directly over a tracking device. How fast in radius per second will the device has to run to accurately track the aircraft when the plane is, let's say, 1,000 feet away? Okay, so 1,000 feet away. So how do we solve this problem? We need to understand what's given to us. We know, and when we're talking about the vertical distance, we can call it a y. And when we're talking about the horizontal distance, we can call it an x. We know that the aircraft is flying toward the tracking device. Okay, so dx over dt, that rate is 450 feet per second. And it's decreasing, so you can think of it as negative 450, okay, going to the left or decreasing. Then you want to find out, okay, how fast the angle need to change. D theta over dt, what is it? In order to track the device. So then we have to relate theta and your x. Now, something is very important that you need to know is what is changing and what is not changing. The aircraft is flying in an elevation 115 feet, and that is fixed because it's flying toward the aircraft. The only thing changing, so y is fixed, it won't change. The only thing changing is x and theta. They change with respect to time. Okay, the closer you fly over the tracker, the angle is higher because it has to look up. So all you really need to relate is theta and x, and y is fixed. So how do you relate theta and x? Well, trigonometry relation. Okay, so it's theta and adjacent. Okay, tangent theta is the opposite, which is 115 is fixed, divided by the adjacent. So that's how you relate theta and x and be able to take the derivative with respect to time and write out all this quantity. So when you take the derivative with respect to time, so d over dt on both sides, you'll be able to relate. So what's the derivative of tangent theta? Is secant square of theta times d theta over dt. That will equal 115 times, what's the derivative of 1 over x? It's negative 1 over x squared. But then it's dx over dt because of the chain rule. And that's a relationship. And then you can solve for the relationship. Okay, so what is secant square of theta? Well, you have to find out what is theta at that point, right? So, okay, this is theta. This is 115 is fixed. But then the question is asking when x equals 1,000. So what is secant square of theta when x is 1,000? So secant square of theta is the hypotenuse divided by the adjacent. Then you take the square, right? So what is the hypotenuse? Is 1,000 square plus 115 square. Then you take the square root. Okay, so the square of the ratio is 1000 square plus 115 square divided by 1000 square. So that you get that quantity. So 1000 square plus 115 square divided by 1000 square times d theta over dt will equal 115 times negative dx over dt is 450 divided by x squared is 1000 square. Oh, then you multiply 1000 square on both sides. Okay, and then you solve for d theta over dt is just 115 times 450 divided by 1000 square plus 115 square. Then you use a calculator to calculate. This is approximately 0.051 radians per second.